Welcome back. In this video, we solve the Chapter 1 practice test on sequences and series. Pause before each problem if you want to try it first, then compare your work to the solution. Problem 1. In an arithmetic sequence, the difference stays constant. Since 9 minus 3 is 6, the common difference is 6. One term before 3 is negative 3, and the next two terms after 9 are 15 and 21. So the answer is D. Problem 2. The row numbers form an arithmetic sequence with first term 1 and common difference 3. The nth term is 1 plus 3 times n minus 1. Simplifying gives 3n minus 2. The answer is B. Problem 3. The terms are geometric because each term is multiplied by negative 1/7. The first 5 terms are 16807, negative 2401, 343, negative 49, and 7. Adding gives 14707, so the answer is B. Problem 4. The common difference from A to B is B minus A. The third term is B plus that same difference. That gives B plus B minus A, which simplifies to 2B minus A. The answer is B. Problem 5. Divide the 20th term by the 14th term. That gives R to the 6th equals 64. The ratio could be 2 or negative 2. Moving back 11 terms from T14 gives T3 equals positive 4 or negative 4. The answer is C. Problem 6. Each radius is 90% of the previous radius, so this is geometric. The first term is 30 and the ratio is 0.9. For the 10th bowl, use 30 times 0.9 to the 9th power. That is about 11.62 centimeters. Problem 7. An arithmetic sequence has a constant difference, so its graph forms points on a straight line. A geometric sequence has a constant ratio, so the changes grow or shrink by multiplication and the graph is curved. Problem 8. For the arithmetic sequence, the middle term is the average of 3 and 27, which is 15. For the geometric sequence, the middle term squared equals 3 times 27, so B squared is 81. Because B is positive, B equals 9. Problem 9. The weekly distances form a geometric sequence with ratio 1.02. 6 years is about 312 weeks, so the total distance is a geometric sum. Solve 17,000 equals a times 1.02 to the 312 minus 1 divided by 0.02. This gives a first week of about 0.7 kilometers. Problem 10, parts A and B. If the sequence is arithmetic, there are 5 equal jumps from 5 to 160. The common difference is 155 divided by 5, which is 31. The missing terms are 36, 67, 98, and 129. The general term simplifies to 31n minus 26. Problem 10, parts C and D. If the sequence is geometric, multiply by the same ratio 5 times to move from 5 to 160. So 5 r to the 5th equals 160, which gives r equals 2. The sequence is 5, 10, 20, 40, 80, 160, and the general term is 5 times 2 to the n minus 1. Problem 11, parts A and B. The distance increases by a steady 17 millimeters per year, so the sequence is arithmetic. The first 5 terms are 17, 34, 51, 68, and 85. The general term is Tn equals 17n. Problem 11, parts C and D, convert 6,000 kilometers to millimeters to match the rate. That is 6 billion millimeters. Solve 17n equals 6 billion, giving about 352,941,176 years. Rounded to the nearest million, that is 353 million years. This assumes the continents separated at a constant rate the whole time. Problem 12, parts A and B. The exposure starts at 30 seconds and increases by another 30 seconds each day. The first 5 terms are 30, 60, 90, 120, and 150 seconds. Since the difference is constant, the sequence is arithmetic. Problem 12, parts C and D. 30 minutes is 1800 seconds. Since Tn equals 30n, set 30n equal to 1800 and get 60 days. For the total exposure, use the arithmetic series formula. S60 equals 60 over 2 times 30 plus 1800, which is 54,900 seconds, or 915 minutes. That completes the Chapter 1 practice test. The key move in this chapter is deciding whether you have a constant difference, a constant ratio, or a series sum. Rework the questions that felt slow, and you will get much faster.